Welcome to The Explainer. Today, we're diving into a really fascinating, scientifically rigorous macroevolutionary analysis of an alternate timeline. We're looking at a world where the famous KPG extinction just never happened, and dinosaurs actually survived to rule a completely altered Earth. Okay, let's dive right into this. What if that 10 to 15 kilometer wide Chicxulub asteroid just missed? What if it sailed right past Earth? In our timeline, we all know that impact triggered a total global environmental collapse, a brutal impact winter that blocked out the sun, acidified the oceans, and basically halted photosynthesis. But what if we take that catastrophic impact winter completely out of the equation? Consider the sequence of events here. The massive volcanic eruptions, the Deccan Traps, actually peaked about 350,000 years before the asteroid even hit. Without the asteroid compounding the disaster, that volcanism alone would have only caused a transient, maybe 2 to 8 degree global warming event. So you'd get some localized ecological stress, definitely some species migrations, but absolutely no mass extinction. The archosaurs, our non-avian dinosaurs, pterosaurs, and marine reptiles, they'd easily survive to completely dominate the Cenozoic era. Section 1. The Dinosauroid. A thought experiment. So, if they did survive, what would they look like today? This brings us to a famous and honestly heavily debated piece of speculative biology. It's a great look at what we typically expect a highly evolved, intelligent dinosaur to become. Now, what's really interesting about this thought experiment is the sheer level of detail paleontologist Dale Russell put into it back in 1982. He actually built a sand-filled fiberglass model based on a real, relatively large-grained troodontid. Russell essentially took a theropod skeleton and applied mammalian pelvic shifts to it. He was actually inspired by a study of a bipedal goat that adapted to walk on 2 legs. The end results? This upright, tailless, humanoid dinosaur packing an 1,100 cubic centimeter brain case, which supposedly fed its young by regurgitation and spoken birdsong. Wild, right? But when we hold that 1982 model up against modern paleontological reality, a massive gap appears. Pop culture totally expects a highly intelligent dinosaur to look like, well, a human in a scaly suit. But the reality is that an intelligent dinosaur would physically remain a dinosaur. It would keep its standard theropod skeleton, complete with a horizontal torso perfectly balanced by a long tail. And that is exactly what modern critiques highlight. The whole idea that the humanoid body plan is some sort of evolutionary default, that gets heavily rejected by experts today, folks like Gregory S. Paul, Thomas R. Holtz Jr., and Darren Nish. The humanoid body plan isn't the finish line of evolution. It's really just a fluke, a highly contingent consequence of primate-specific movement in the trees. A smart dinosaur wouldn't just suddenly sprout human hands. Instead, it would manipulate objects using its beak, its snout, or even prehensile feet, very much like modern corvids and raptors do right now. Section 2. Cognitive evolution. Brains and oxygen. But hey, anatomy is only half the story here. To really grasp dinosaur intelligence, we need to transition away from bones and look at the actual biophysics of cognition, specifically the atmospheric chemistry that governs how brains evolve. Because think about it, brain tissue demands a massive amount of energy. It requires super high rates of cellular oxygenation and incredibly efficient carbon dioxide removal. And just think about the stark difference in atmospheres over time. Back in the Mesozoic era, atmospheric CO2 was sitting at an incredibly high 1,000 to 6,000 parts per million. That kind of atmospheric chemistry literally restricted cellular respiration across the entire animal kingdom. It acted as a hard biological ceiling, physically stopping brain tissue from growing past a certain point. But if we jump forward into our alternate Cenozoic, the Earth cools down, and that oxygen to carbon dioxide ratio rises. This massive atmospheric shift would finally lift those ancient biophysical constraints. Surviving Maniraptoran clades would at last have the biological fuel needed to encephalize, to actually grow large brains. Though it's absolutely crucial to note that even with big brains, they would still retain purely archosaurian neural structures. And speaking of dinosaur neural structures, let me throw a massive number at you. 3 billion. Back in 2023, neuroscientist Susanna Herculano-Hausel made the claim that the mighty T-Rex actually possessed 3 billion telencephalic neurons. That staggering number would theoretically give the apex predator the cognitive capacity of a modern baboon, maybe even the potential for tool use. Well, as you can imagine, that claim did not go unchallenged, sparking a pretty fierce scientific debate. Researchers like Kai Kaspar and Darren Naish countered that those massive neuron estimates relied on some pretty flawed assumptions about the volume of the dinosaur's brain cavity. They pointed out that in archosaurs, relative brain size is a much, much better indicator of intelligence than just an absolute neuron count. And while some had hypothesized that endothermy, being warm-blooded, might have triggered a cognitive arms race, the fossil record just doesn't show any corresponding leap in brain complexity. So ultimately, the modern consensus firmly shuts down the whole primate-brained T-Rex theory. Dinosaur cognition remained fundamentally reptile-like. Section 3. The mammalian ceiling, ecological exclusion. Let's move on and see how this builds into the story of our own mammalian ancestors. If the dinosaurs never died out, what would have happened to the specific lineages that eventually led to us? Look, we've all heard the traditional narrative, right? Big, scary dinosaurs oppressed those poor, tiny early mammals, keeping them scurrying around in the dark. But a 2021 study by Brocklehurst and colleagues exposed a totally different modern statistical reality. It turns out our direct ancestors' biggest bullies during the Mesozoic weren't actually the dinosaurs at all. No, the true competitors were actually other, non-modern mammalian lineages. Groups like the Eutrichodonts, multiturbulates, and drylistoids. They were incredibly diverse. They were occupying swimming, gliding, and climbing niches. In fact, large predatory Eutrichodonts like Gobicanodon actively excluded the ancestors of modern placentals and marsupials from prime ecological real estate. So while all those classic mammalian traits like fur, lactation, and a complex middle ear evolved gradually across a bunch of lineages, our specific ancestors were getting held back by their own extinct cousins. So the crucial point here is what we call the no megamammals rule. Even if our early mammalian ancestors survived the Deccan Trap's volcanism and somehow outlived their non-modern mammal cousins, they'd still slam right into an unbreakable physical ceiling. Why? Because dinosaurs already firmly occupied literally every single large-bodied herbivore and carnivore role on the planet. Mammals were physically blocked from bulking up. In this alternate timeline, mammals would still be highly diverse, sure, but they'd be permanently restricted to the size of rodents, mustelids, and small primates. Section 4. The Canopy Crucible, Pterosaurs versus Mammals. Because mammals were blocked from growing large on the ground, they had to look up, and this takes us into a visually striking, fiercely competitive environment, the Alternate Cenozoic tropical rainforest canopy. This canopy would become an incredibly intense arboreal crucible. You see, tropical forests are super sensitive to climate shifts. Minor fluctuations would periodically wipe out the species living up in the trees, leaving those high niches completely wide open. And the dinosaurs? Massive ground-bound sauropods were way too heavy, and theropods had those reduced front limbs, meaning they were anatomically restricted from climbing. They were permanently stuck down on the forest floor. This created a massive, high-stakes battle for the canopy. Small mammals would race up the trunks trying to claim those vacant niches, but waiting for them would be flightless pterosaurs. And here's the thing, unlike birds whose wings are really only good for flying, pterosaurs had wings structurally closer to arms. As they reduced their flying abilities, they'd use those robust, folded wing structures as weight-bearing, highly manipulative climbing limbs. Thanks to that massive anatomical advantage, giant flightless pterosaurs would structurally outcompete any mammal trying to make a living in the trees. And honestly, the nightmare for mammals wouldn't end there. The canopy would also be prowled by what we call arbosaurs. Picture this: highly specialized, terrifyingly agile, tree-climbing theropod predators evolving specifically to hunt small mammals in the high branches. In our real timeline, we know constant predation pressure from snakes helped shape primate vision and brain evolution. But in this timeline, the constant, lethal pressure from climbing arbosaurs would exert just massive evolutionary forces on our trapped mammalian ancestors. Section 5. A cooling world. Grassland adaptations. As we jump forward into the Oligocene and Miocene epochs, the entire planet begins to experience a long-term global cooling trend. This climate shift dried out the forests and gave rise to expansive, open grasslands. And this brilliantly illustrates why dinosaurs were just so completely unshakable. Cenozoic grass is incredibly abrasive. It's packed with silica that rapidly wears down teeth. In our real world, mammals had to go through this long, costly evolutionary process to develop high-crowned teeth just to survive out on the plains. But dinosaurs? They wouldn't have to wait. They were already biologically pre-adapted to conquer this exact environment. They possessed these incredibly complex dental batteries, made of undulating layers of hard enamel, soft dentin, and cementum that ground against each other to create an endlessly self-sharpening surface. They would have literally chewed up the new grasslands with ease. Which leaves us with a truly provocative question. If the asteroid had just missed Earth, and if our mammalian ancestors were permanently blocked from growing large on the ground, trapped in the high canopy, constantly outcompeted by flightless pterosaurs, and hunted by specialized climbing arborosaurs, how do you think human evolution would have fared? Would we even exist? Or would intelligence on Earth look entirely different today? It really refrains how fragile our presence on this planet actually is. Thank you so much for watching this explainer. I really hope you enjoyed this deep dive into speculative biology and evolutionary science. Please don't forget to like and subscribe for more deep dives into complex science, and I will see you in the next one.